Hey everybody, welcome back to Zappletech Meetups for test automation. And again, I am your host, Paul Grossman. I'll be here for the next 2 hours, and I've got some really great stuff here for you. And we've got two fantastic speakers who will be bringing on in just a few minutes. We're going on a little early here, about 15 minutes early, just so that we can kind of get the word out, get people to come on in, join in here. So if you are just joining in the last few minutes, don't worry, you're early. And I'm going to be talking a little bit about some of the cool stuff in test automation that's going on today. And then we're going to bring on Rafael Cintra. Rafael Cintra is a fantastic speaker. You're probably going to enjoy him. He's works in solutions engineering at with Value Ops at Broadcom. And I think he's going to be a fantastic speaker out there working with all sorts of stuff. I believe he is Safe 5 certified. So Safe so he's Safe 5 as certified, and let's see. All right, cool. I'm just getting a little bit of notes from my background guys here, so I'm trying to do two things at once. That's one of the things that I do not do well with being a test automation engineer. That is trying to do two things all at once over here. But yeah, Rafael's a really good guy. By the way, I was mentioning SAFE certified, so I'm also SAFE certified. What SAFE means? Well, that means scaled agile framework. Scaled agile framework, and scaled agile is basically kind of like agile, but on steroids. So most of you today, most of the people who are working in today are in the agile environment, and agile means that we are going on. Agile means we are having stand-ups every day, and if you're not used to that, it's interesting. Stand-ups every day doesn't mean you have an hour-long meeting every single day. We don't try to waste our time doing that. We have stand-ups, and basically we gauge how much time the meeting lasts by taking the number of people who are in the meeting and multiplying it by 2. That should be the total number of total time that it takes for your stand-up meeting to get done in an agile process. So let's say I've got 5 people, and I'll be the Scrum Master, which I've been doing for the last 2 years, Scrum Mastering meetings on this. And then you have if you got 4 people on there, if I'm the Scrum Master and I'm not actually giving any updates, then that's 4 times 2. It should be about 8 to 10 minutes for the stand-up meeting each morning. You don't necessarily need to be there every single day. You can catch up. So that's kind of cool. One of the things I do in my approaches, and I got this from a fantastic company, this from Redbox, my experience over there. Those guys are so agile. What they were doing is they were actually watching videos of other companies to see what they were doing for agile, and looking for videos on YouTube to see if they could steal those ideas. Go with it. So one of the things about agile is that what I do from what I stole from Redbox was that we don't do stand-ups on Friday. It's Friday is get stuff done day, because we don't want to be spending our weekends trying to prep for something that's coming up on Monday. So, I see a couple of informations and stuff coming over here. Fantastic. All the information about this meetup, by the way, is in the description under the video. So if you're looking for that, go check that out. And talking about the DevOps roadmap over there, Vishal, welcome. By the way, Vishal, hi. I actually do see the messages popping up over here. As I said, Fridays we don't do stand-ups. It's Monday through Thursday, and Fridays it's just get stuff done day. I will have meetings with individual people on my team and say, hey, let's finish some stuff up. Let's figure out what's going on. Is there anything that we can do to help you get things started? Um, so that's agile, right? And there's also you have 2 week sprints, and at the end of the sprints, we do demos, and we start planning for the next sprint. What are people going to do? What are they trying to wrap up? And the best thing that I do in QA in the QA part is I also track all the defects that I find. So when I'm doing that, I'm just keeping track of that in my own individual project, in Jira, and at the end of the 2 week sprint, I actually go and put together a document. Now I'm a manager; I have to put documents together, so I send that over to my project my manager, and it basically lists all the things we were accomplishing, what were our blockers, and what was our defects that we found. And the most important thing I put on that document, it's just a 1 page document, is I put screen captures of whatever is going wrong to put in there. And that basically is to show our return on investment. Because what's our ROI? Our ROI, our return on investment, is what happens when we are trying to get prove that we're doing good things here. We're trying to keep bugs from getting into production, right? So if bugs get into production, that costs the company money. So what I usually say is, go take a look at what your company made, last year. It's publicly listed out there. Go take a look around, or take an estimate of what it is, and divide that among the 365 days of the year. Subtract 10 days for holidays, probably not in the office doing much, and then divide that again by 8. So assuming we have an 8-hour day, whatever that number is, if your website is down for that hour, that's how much the company is losing. That's what we don't want to happen in QA. So that's what makes us really valuable to our company. Now, one other thing I want to mention is that there's a problem with this, because if we do our job really well, it looks like everything's fantastic. The developers look brilliant because, if there's any mistakes, we keep it in QA and we tell them and they go fix it, and then we fix it and we push it out to production. Hopefully, we don't find anything in the production. The problem is that there is the idea that, hey, the software's so good, the developer's so great, who needs a QA department? Now, one of my original mentors, Linda Hayes, she told us, hey, if you want to get rid of all the defects, just get rid of the entire QA department. And people kind of laughed at that because, it's a joke. You won't know about what's out there. You definitely need a QA department, but the problem is that we don't necessarily know exactly what's happening. What does QA do for us that keeps us, solid and viable to our customers? I call it the George Bailey effect, right? For those of you who don't know, there's an old Christmas movie called "It's a Wonderful Life" with James Stewart, and he basically decides the world would be no better with him or without him. But an angel comes down and shows him what his life would be like if he wasn't there. I take the same approach. Take a look at what your company would be like, what your bottom line would be like if you didn't have manual testers and automated QA testers sitting there trying to keep your defects from getting in production and losing you money. So that's the important thing out there. It's just keep a good QA department, keep them happy, keep them fed and warm, and make friends with your developers. That's the best thing I've learned. Currently, I'm actually working at a company called Guaranteed Rate. It is the most fun, best environment I've ever worked with over there. These people are just fantastic. And the only next best bit of advice I can give you is don't tie your hands of your QA people behind their back. And what I mean by that is, like, if they need to have some Chrome extension installed, for example, Selectors Hub, but your IT department says, no, we can't have that. Now, get your automation going together. Just figure out how to make it work without that. It's tying your hands behind your back. QA SStat employees, staff members should have the exact same rights as the developers. And if they don't, it might be time to go look for another company that actually does that well. That's one of the things I do when I talk to people and ask them, what their environment is like, and they'll say, "Oh, you can't install any of these things." I'm like, "Well, I'm sorry, I'm looking for something a little bit more professional level." Cool. So let's see. We've got about 4 minutes before we bring on our first speaker. That's Rafael Cintra. And after Rafael speaks, we're going to have. I'm gonna mess this up. There's so many accent marks in his name. I'm pretty sure I'm going to put the wrong emphasis on the wrong syllable. So my apologies. But it's Péter Földházi, and he's going to be speaking a little bit about. He's a lead software test engineer over at EPM Systems, and he's going to be telling us some really good information out there. Thank you, Peter. He just confirmed I said it correctly, so I did put the right emphasis on the right syllables. Thank you, Peter. Let's see. So we got, like I said, about 4 minutes left to go. I'm trying to think of what else we can talk about. I talked a lot about Agile, some of the processes out there. It's really a good thing to do to learn how to do, and to get get you on the right track so we can get things taken care of and going correctly over here. Let's see. I am looking to see if well, I guess we're going to go a little bit more. I do want to thank Zappletech for hosting these events. In case you missed last month, I was also the host last month, and I just learned I'm going to be the guest speaker for next month in August. So I'm going to be showing you a little bit about test automation in what we talk about plain English, low-code test automation tools. And I've found one that you can just basically click the OK button, and it will go and find a button with OK inside of the locators, and then go click on it. It's pretty darn easy. I will tell you, it's a hard sell to STETs because they say, hey, what's for me to do? Is there any code for me to write? Literally, it's in the name, low code automation tool. I was one of those people for quite a while. Said I'm not a fan of low code tools, but basically, I do see the advantage of having manual testers skip that ramp up time. Skipping the ramp up time to get to learn Java or JavaScript or Python or Ruby or whatever it is that you happen to be using. So we're the interesting thing is these tools that we're using for test automation, which are which are manual low code automation tools where manual testers can actually start writing scripts. But I'm basically giving away what we're going to talk about. That's going to be in August next month. So I do hope you guys mark it on your calendar. Come on over and stop by the Zappletech meetup, and we will be there. In just about a minute, I'm going to bring on Rafael, and he's going to give us a great presentation coming up over here, and I'm really looking forward to this. This is great, and I guess we're just a few seconds away on doing that. As you can see, I'm a little bit of a fan of Rick and Morty over here. I got Rick over here in case you're wondering about what's in the background. And by the way, if you're wondering what this computer is over here, this is an Amiga vampire. Now, let me tell you something. This is a vampire just like real vampires. When you look at an Amiga vampire, you say, first of all, didn't you die 30 years ago? That's true. It also has an updated chipset, so it runs 10 times faster. It's just like a real vampire. You're 10 times faster than I remember you being. And lastly, it has an amazing graphics output. It's got HDMI, which wasn't even in existence back in the 80s when that thing was built. All right. Hey, everybody, thank you so much for this little stretch here. I'm going to bring up Rafael Cintra. Rafael, pleased to meet you. Let's go check your mic and see if everything is working.
Yep.
Hi.
Hey, Paul. Great introduction, by the way. I was in the backstage,
Hey.
just listening you talk, and I really like your Back to the Future car right there. I think it's a car anyway. It seems like it's a DeLorean.
Oh yeah.
Great setting. Yeah.
I got two. In fact, here, watch this. See, the problem with the test automation is that every time you go back into the future, the car gets smaller and smaller. I can't fit in it anymore. All right.
Awesome.
Got
Awesome.
it.
Yeah.
Yeah.
And great
All
great
right.
stuff about your talk next month, I guess, right? About the low
Yes.
code test automation. Yeah, I'm
Yeah.
really looking forward to that one as well.
You bet. I'm looking forward to presenting it. Well, without any
Awesome.
further ado, Rafael, I'm going to hand this over to you and take us away.
Thank you. Let me just share my screen. I guess you can see my screen, right? Just checking. I think so. Yep. Okay. So guys, welcome to another Zapple Tech meetup. I'm I have an interesting theme today, which is how to apply a design thinking prioritization grid approach into quality engineering, and that's pretty much a fancy way of giving you some insight on how to have a tool, which is the prioritization grid, which will help you prioritize your test cases, and also from those test cases, the ones that you should be looking into automating. So I'm gonna start presenting myself a little bit, and then I'll dive us into the topic itself. So as Paul mentioned, I'm a solutions engineer at Broadcom. I'm focused on the value ops side of things, which is pretty much connected to Agile at scale, like SAFe and those things that Paul mentioned as well. I also speak a lot about and work with DevOps solutions as well. I have an extensive experience with QA and DevOps through a set of different companies in almost 14 to 15 years of experience. I have been a software development engineer in testing, as Paul was mentioning about the low code. I don't really, I'm not fan of low code tools, but I'll certainly look up for Paul's presentation next month. I do have 19 docs. That's right. You probably hear it correctly. That's 19. Which of those 18 are chihuahuas? So you may hear some barking in the background, but I'm guessing they are probably sleeping right now. So uh, we won't get much action from the chihuahuas. I do have a lot of experience with banking, insurance, and finance in general. Some people don't like to work with financial services and banking and insurance, but uh, uh, most of my experience is working either within those companies or for those companies. So I'll probably, if I use examples, you probably was working for a bank or insurance company. And I do love to speak in general, but also as a speaker on meetups, talks, presentations, and things like that. I have participated in other types of events, and my focus currently is mostly focused on trying to connect different things to help us as quality engineers, as testers, as test automation specialists, or whatever uh, title that you have on your company, so we can try to start thinking how we organize our work, or that we learn new tools to do our work on our day to day. And that's one of the reasons why I'm trying to connect design thinking to with test automation and testing in general. So a little disclaimer, this is not your standard test automation talk. We're going to learn a little bit about quality engineering and smart prioritization, and the house in the background, which is being renovated or built, is not by accident. So when we talk about it's probably something which is a must during some type of home renovation project. Probably a lot of you have tried to renovate a bedroom, or even add something to your house or to your home, and you know that's not an easy task. You have to understand where to start, what to prioritize, what do you actually need, and some things which are something that you can leave it for the future, or that you don't need right now, because you have to make sure that you take all that in consideration. Have like budget, you have amount of money that you can spend, you have amount of time that you you can invest on your renovation. You probably will be living, if you are renovating the house that you are living right now, you probably want to make sure that you are as efficient as possible while prioritizing what you're going to be working on, so you don't have a renovation that takes like months or years, or even if it's, we also don't want something that is too fast, but once we are done with it, we have issues or problems, or we have to keep renovating because it's a never ending problem or project. So that's the question. How do we do that? How do we prioritize in an efficient and in a smart to kind of know exactly what is the actual impact for our customers and for ourselves if we're talking about renovations, because we're going to be the end customer, and how we compare that to actual feasibility, because we we always want to have the best bathroom, the best pool, the best living room, the best appliances, but there's a kind of a negotiation happening, that you have to choose what you are doing, how you are doing, and in which order you are doing. And even though you have like unlimited time and unlimited money, at some point you would be so fed up with the renovation that you would just say, I'm done with it. I can't take it anymore. And that's the same thing with testing. We could have all the time in the world, we could have all the resources in the world, and we know ourselves, we would be wanting to test every possibility, we would want to test every possible scenario. I hear a joke in a event that I went to recently, that somebody said that if a QA guy or person or whatever, he goes to a bar, he's gonna try to order the entire menu, he's gonna try to buy a car, he's gonna try to get food for his dog, he's gonna try to sit on the bench, he's gonna try to sit on the chair, he's gonna try to sit on the table, he's gonna test the bathroom, he's gonna want to test the kitchen, he's gonna want to test if the waiter knows all the different options of the menu. So he's gonna try to do pretty much everything, and he's gonna try to break everything. So the whole idea is that we don't need to do that. We don't need to test every possible scenario. We need to prioritize, because we're all working, or hopefully we are all working on agile teams, which have sprints, which have like time boxes. So we don't have time every sprint to test everything. So we need to have a way to prioritize what we are testing, and from what we are testing, what we are automating. So where does the prioritization grid comes from? The prioritization grid is a tool or a technique that is part of the design thinking framework. I'm not gonna get into much detail on exactly the entirety of design thinking and all the different tools and techniques that you have available. But if you want to look up more information on the the base or the reference prioritization grid that I have used to create what I'm going to show you guys, it's design thinking prioritization grid. If you Google that, you'll have more information. I'll add some references on the material as well. But basically, design thinking is a user-centric framework, so that's why it has all these different tools and techniques to solve a business challenge while looking for to deliver the best experience for our users. And we as quality engineers and quality engineering teams, we also want to make sure that our software works also, but it also delivers the best user. I'll be proposing here, and you'll see in a couple of slides, is how can we make sure that we assess the impact for our users and also the feasibility for what we'll be testing, and making sure that we focus on those areas where there is an intersection. And there will be a logical explanation why you should focus on this one first and then in that one. But that the original one, the one that gave kind of birth of all that, comes from the prioritization grid within design thinking. So if you want to know more, or if you want to expand your knowledge, go look for design thinking prioritization grid. I do have some other talks on those topics as well. If you want to hit me up on LinkedIn or whatever, we can talk about it. So the whole idea of everything that you do with design thinking is you diverge. You ensure that you list all the test cases. You make sure that you understand the whole scenario, so you can have all the different perspectives on what you're doing from your team, from your Scrum team, from your developers, from your QA people. Then you clusterize. You make sure that you uh, s- get everything that looks similar or which is similar because even though we have a diverse team, we probably want to test some of the same things or most of the same things. So you put all those together, so you can converge, so you can make sure that you have uh, an inclusive picture of what you want to do or the product that you want to build or what you're going to be testing on your software. And what exactly is the prioritization grid? The prioritization grid will be a chart that will help us identify which ideas to act on. That's the original one, the one that comes from design thinking. So the idea is kind of think of as a waiting in who stays on and leaves an island. So the idea is that you kind of understand where you need to go, what you don't need to go right now, and some things that you can leave for the future because they're probably not going to be something that your user is going to be doing, so you shouldn't be focusing on that anyway. And the whole idea, it's an actual chart, so you have impact to the user and feasibility for us, and us here it's pretty much the development team who is working or the actual team creating that product. So you have high and low for impact to the user, and you have hard and easy as feasibility for us. You will see that in the next slide. I kind of use that approach to create our own prioritization grid for testing, and in some questions that we can have to kind of balance those two things. So we focus on testing what will have probably the most impact to our users, and also the hard to easy for us. So we make sure, so the idea is that we kind of focus on what has the most impact and which is easier for us first, and then we move on to the other ones. So when I talk about prioritization grid applied to quality engineering, the idea is that we'll have a chart that will help us identify where to focus our testing strategy. And I could have replaced testing strategy with test automation, with testing, with pretty much everything that we are doing within QA. But the whole idea, why I'm using quality engineering, because the idea is that we bring some of this new mechanism of this engineering of design thinking into the way that we are going to be planning our tests. And what I'm going to show here, you can use if you are an actual agile team on your planning, or while you are planning your testing for your user stories, while you are trying to understand which scenarios you need to focus on for your team to test. And also, if you are, and hopefully there's few of you out there who is doing waterfall, but you would be able to use that as well, because what I'm showing here is an exercise that you can do either for the water, or either for agile teams. But the idea is that you can do like for a larger, broader perspective of your team, of your backlog. Let's say you have an entire project, or even like a small backlog of a sprint or a release. But the idea is that you can apply to each of those settings, to each of those perspectives. So you can do like a big session, or you can do like small sessions to focus on your user stories and prioritize the testing for those stories as well. So what does it look like when we get that chart, that prioritization grid, and we make this mindset when we apply this of quality engineering? So I'm gonna keep the impact to our user, because that's pretty much the one that's going to be affected if your system is not working as expected, or if it's not working at all, or this is the one that you should be concerned about when you are trying to test. So if we go back to the bar example, or the restaurant example that I gave earlier, uh, usually people are not going to order the entire menu. People are not going to try to test every possible scenario in the bathroom on the every stall, or they are not going to try to check your kitchen every time, or every customer will want to do that. So that's kind of a little bit of the mindset here. We need to make sure that we are focused on what is the most impact to our users, and then we will have like a progression on feasibility. So we start with the ones that are easier for us but have the most impact to our users. Then we progress to some of the ones which are also impactful to our users, but they are not as easy for us. And as we progress on that line, you probably have different focus on should I be automating on this one? Should I not be automating on this one? And I also have a couple questions that can help you how to understand the feasibility for testing. Obviously, if you have a different uh, grade or a different standard for feasibility, if you have your own team kind of feasibility grade, and you have from A to B or from some other parameters that makes more sense for you, that's fine. You can keep using that parameters as well. The whole idea here is that you think about feasibility and that you're going from which ones are hard to ease, so you can use them with the chart itself, so you can focus on the ones that are more impactful, and then start with the easy ones and move from there. So how do we do that? How is the process of actually applying that prioritization? So we have basically 4 steps, which is we're gonna pretty much, you have to list all the scenarios that you will be working on. Then you vote on those scenarios. So you really converge on what are those scenarios, because probably the different people, the different members of the team will want to test all these different possible test scenarios. So in some cases they will agree on the scenarios, in some cases there will be additional scenarios that somebody thought about it, but we don't think that needs to be clusterized. So you start, creating an inclusive perspective on what needs to be tested. That's not the final answer yet. We'll keep using that information as we move forward, and we make sure that there's some type of agreement as we move forward, so the final answer will make sense to the entire team. Then the second step is to plot. Design thinking and those tools in general that design thinking gives us, they are pretty much visual. And I know that when we were pre-pandemic, that we were all working together, without home office or in a physical setting. We would do with post-its and actual like boards and things like that. But if you are working entirely remote, you can do that as using a Muro or Miro or some type of other tool that we have available now. But the whole idea is that you give some visualization. People have to really see the little post-its and the little test cases, and making sure that everybody sees what everybody added to the entire perspective. The third item is going to be to adjust. So we'll need to review and adjust what needs to be adjusted, to check if anything needs to be changed, or what needs to happen. But the whole idea is that you have everything plotted. Now you can have the entire perspective. And the last step, which is the assess, which is exactly, well, you will look at your day. These are the ones that I should be focused on. These are the ones that I can focus on after I'm done with the other ones. And then you will have different groups, so you know which tasks you need to focus on for that scenario, and they will be in a logical setting. So first go to these ones. This is where I will probably automate most of my scenarios. And you go to the second group, and then you go to the third group, and probably at the last one, it's probably test cases or test scenarios that you don't want to focus on right now, or even ever, because the whole idea is that your user either doesn't have too much of impact if that is not working, or it's not working as expected, or even because it doesn't make sense because it's too hard to do or even impossible in some cases. So how can we do that for quality engineering? So the first step is to list all our test scenarios. The idea is to have one test scenario per posted, and you're gonna say, well, but how come we're listing all test scenarios? And the all here, it's all test scenarios for each team member that is participating on the exercise, because they are probably gonna have the same test scenarios. I will want to test something that my colleague will want to test as well, but my suggestion is keep those post-its separate, so you can clusterize them later on, so you know that two people of the team had that same perspective. So the idea is that you list all those scenarios, and don't really focus on the idea of all test scenarios. It doesn't mean that you have to think about all possibilities, as I was saying before, but for you, with the knowledge that you have from the product, or for the intended product, if you are building something new, or for the system, or looking at post bug data, or by the experience that you have with testing that software, what are the test scenarios that you for yourself would be the important? So, and then we're gonna vote the test scenarios. And how we're gonna be voting those scenarios? We're gonna be giving them different colors, and the colors here are pretty much whatever different colors you want. I have used blue for impact and green for testing feasibility. So the idea is that we vote on those test scenarios based on those two parameters. So we have our chart properly colored, so we can use that information to group them based on the impact to the user and feasibility for testing. And then all this will be plotted. And if we did this like in a with actual bits and physically, we probably want either to take a picture or to translate that into some digital tool to make it easier, so we can translate that into actual testing strategy, or to whatever tool that you use to have your strategy and to actually map your test cases and the ones that you're going to be using. We're going to review and adjust to make sure that everything is really the way that we agreed on, and then we're going to assess to know the ones that we'll be actually testing and or automating. So we're gonna talk a little bit about what does impact to the user and feasibility for testing means. Those are the main questions that I brought based on my working with those exercises on a couple of the teams that I have been working on. So when we talk about impact to the user, what are the questions that we are actually looking for to answer when we are thinking about impact to the user? Because it's important that when we are doing this prioritization, both the impact and feasibility for testing are kind of a common concept. So if my concept of feasibility is different from the concept of feasibility for my team member, we'll probably evaluate things differently. So the team doing the exercise needs to understand the concept of impact and feasibility. So when I talk about impact, what are the usual questions that I recommend the teams to look for? It's does it does this test, does this scenario that I'm thinking about, does it turn a pain point into a crisis? So if that is not tested, or if it's tested but it doesn't work, what does that mean for my user? It's something that would be a crisis. It would be something that endangers the whole system, or the whole ecosystem, or even does it decrease user value? So if something is not working because it was not tested, or it was not tested in every possible scenario, if that doesn't work, does it decrease our user value from our product? Does it directly impact the user experience? Because in some cases, it's something really small, or something which is not in the main flow of the software or the product, that if it doesn't really work, or if it's not entirely tested, and something goes wrong, or if it's not working as intended, it's not going to directly impact our user experience. So it's probably something which would have less impact to our user. Does it wake people up? And this is not a joke. So if something is not tested and doesn't work, or if it impacts our user, he or she customer service, which will then call somebody on standby, which will have to understand what is going on with the system, why the system is not working, why I can add items to my shopping cart, or I can't really process my shopping cart. So what exactly is the impact of that item to your user? And it's not for us, it's for the user. So understand who your user is, what his intentions are with your system, with your software, or even with the feature that you are working on. And and you can add other different questions if you want to when you are doing this with your team. But the whole idea is that you think about the user and the impact to the user. And when we talk about feasibility for testing, so is this something that we could do manually? Because if it can only be done manually, this is probably something which I can do, but I would not automate it? Can we actually test this in our test environments, or is something that our user does, but I can't really reproduce in some cases? That answer will probably kind of give you other items that you need to work on. You probably need to work on your test environment. You probably need to work on your test data. You can probably ensure that in some cases you're going to be testing something manually, but not automating, or the other way around, or automating and testing manually. So the whole idea is we need to ask those questions so we access and we evaluate feasibility correctly. So can we automate the test data on the scenario that I'm looking for? Because if we can't keep it consistent, if I can test every time with the same set of environments, with the same set of data, that's probably something where the feasibility will go higher, and probably something that if it doesn't have too much of an impact for my user, I'll leave it aside and I won't worry about testing it, or I'll test it manually but won't do it with automation. So think about those things when you are evaluating the feasibility of that item. Also, is it technically feasible to automate this? We need to make sure that we think about what we are doing now and in the prioritization, but we all want to automate. We all want to have as much as we can test automation. So the whole idea is you also need to take feasibility as far as we automate this or not. And the last one, which sounds funny, but I have seen some cases of this in the future, is this scenario even possible? Is this not a case of I'm trying to making sure that I'm testing all the different possibilities, but our user will either never go through that flow, or this is a probably impossible scenario that nobody even cares, or that the scenario doesn't make sense because I can't really add something to the cart and try to do a type of payment that it won't be available for that type of product. So we need to take that in consideration here as well. And now that we evaluate all those different scenarios, when we add that to the graph, when we kind of put all that together, we'll have the different groups of tests, and kind of the whole idea of where you need to focus your efforts. How can you actually know what you're going to be focus your automation on, and what exactly are the things that you probably shouldn't be doing right now, or that you probably should look into doing but in a second set of sprints or in a second release. And that will give you an entire perspective, even for the things which will probably be too much difficult, that aren't doesn't make sense, or that you don't want to focus right now because the impact to the user is minimal, and we don't have too much of a value by either testing that or even automating that. So we have four groups, which are the no-brainers, the big bets, the utilities, and the unwise. And I'll go one by one. So the ones which have kind of the most and they are the easiest ones, they're gonna be the no-brainers and the big bets, with a kind of a different grade here. But the idea is the no-brainers obviously are gonna be the ones that you should be testing, the ones that you should be focused on, that as your sprints progress, you need to make sure that those are being tested. And sorry, those are the ones that you need to make sure that you test and that you automate. Everything that you automate should be out of the no-brainers and a little bit of the big bets, but obviously the no-brainers will be the ones that you need to make sure that you test at every release, every sprint, that are probably something that you need to add to your regression test suite. But you start here. Those are the ones that you should be looking into automation. The second group, which is also probably tasks you would benefit doing, but they will only be done when we are actually looking at the I'm gonna say done with the no-brainers, but the sense is in some cases you are almost done with the no-brainers and you can move into some of the ones classified as big bets, because those are probably tasks that make sense, but they don't have as much as an impact to your user, or even if they have a higher impact to your user, but they are too hard to do, or they are harder to do than the no-brainers. So we don't want to focus our team and kind of get our team tired or exhausted on trying to work first on everything that it's hard but has a high impact, because you're going to lose a lot of time, you're going to be investing a lot of effort. So the way we organize this is we start with the no-brainers, which are the easiest ones and the ones which have the highest impact. Then we move into the big bet ones, which also have a good impact, or even a higher impact on some of the no-brainers, but they are harder to implement, they are harder to test, they probably have some type of dependency, they are in some cases some things which we can't automate, or in some cases we can automate some of those, but the type of code that we need to generate for those scenarios, it's too complicated, or needs to have all the different error handling scenarios, or they have to handle all these different flows, which will be flows which are impactful to our user, but they need more investment, they need more time, they need more they need more investment from the team to be tested and automated. Then if we are done or almost done with the no-brainers, and we have looking into the big bets, and we are satisfied with everything that we did there, we have the utilities. The utilities are probably, that same variation of that same scenario that you have already tested, with the basic stuff, with the essential stuff. I don't like to use the word basic here, but anyway, it's just you have done the essential ones, you have done the ones that matter, and they are easy to test as well. They are probably something that you would just say, okay, I have this automated scenario, if I just change this step on my flow, I could probably add 2 or 3 or 4 more automated scenarios here, because I'm changing just one step of the flow. And that's usually uh some of the scenario that I see in some teams that I work with, because they're like, no, I have 10 tests automated already. If I just variate or diversify this step, I can say that I have 20. And most organization, especially the big ones like banks and insurance companies, if they are still going through a change of mindset or a change of culture, they're like, I want to automate as much as possible, and they are in a trap where it's pretty much, I'm just gonna do different variations of a scenario that it's already tested enough. You didn't need to really do that. You didn't really need to uh, add that scenario. So the idea of the utilities are things that will only add to the basic expected set of deliverables. So I'm not testing a different flow. I'm not testing a different functionality. I'm pretty much just doing more of something that I have already done. So what do you want to do here is not just say, I don't want to look at those, I don't want to test those, I'm from here. In some cases it won't make sense, and that's a discussion that you need to bring to the team. And even though we have kind of a process here where we are classifying our groups of tasks, the whole idea is that this is actually an input for your team to discuss their quality engineering strategy, their testing strategy. So these are the ones which will probably you want to flag somehow and say, we need to look into those guys, into that group every release. Or if we are doing regression, those are probably some scenarios where maybe right now he is not really something else, or he's just basic, but probably in the future, as you keep doing this exercise or keep revisiting this exercise, probably this one can move into a big bet or a no-brainer because of how your system progress. So the whole idea here is you'll probably have some automation here, but either it will be not really cost effective, or it will only happen as your system progress and the test here or the scenario changes from utilities to some other group. The unwise ones are probably the ones which are too difficult to test, not even automating, but to test. So the whole idea is you probably want to keep those at bay. You don't want to focus too much on those tasks. You just want to make sure that you have mapped those, but they have so very little user value. So see, I'm not saying that in some cases they are easy or not easy to do, but the impact to the user is so little that I don't really need to test those. I don't really need to kind of be concerned about those scenarios, because I won't really change my user mind or life or journey if I don't work on those scenarios. So in some cases, and as you can see, the unwise, they are here at the bottom because probably they are also hard to test. So it's either something that you can reproduce every time, or the data is too hard to obtain, or even if it's the data is available, the type of integrations and the environments that you need to have available are too intrinsic or complicated, that if they impact little, let's not be really worried about this. Let's just not looking into this right now. Let's focus on everything else. And the whole idea is you probably will do this exercise either for an epic or a story, or mostly for stories. If your system is evolving, probably your story is related to another. They are probably evolving functionalities which are within your system. So the idea here, you will do this exercise on one sprint or for one release, but you need to keep an eye out for, as your system evolves and as your functionality evolves, you will probably need to revisit your classifications to make sure that if you had something here in the utilities, if that didn't change to a big bad, or if a big bad didn't change to a no-brainer. So how frequent you're going to be doing that, that will depend on your system. So my guess is the reclassification or redoing the exercise or a small version of it, what we have seen work for us, it's actually when we are thinking about regression, or when we are thinking about a couple sprints from now, or in different releases, we need to make sure that we revisit that scenario, or that's those scenarios, so we make sure that we still have a clear view of the impact to the user, because that's something that we always forget. The systems are not static, evolving, and as we move more and more organizations and teams working in agile fashion with several sprints, several releases, we want them to evolve the system. We want them to add features to the system, and we are either changing the system and how things interact with each other, or we are adding new functionality to the system. So our systems, they will keep evolving. They're like a living organism, so our strategy needs to be as well. So this is not an exercise that you will be doing one time, or at one release and just forget about it, and then that information will be static. No, the idea is that you do that recurrently, at the same time that you are probably planning your tasks. You are making sure that you classify in different groups, always thinking about the impact to the user, the feasibility for testing, and it's crucial, as I said before, that the concept of impact is clear to everybody on the team, and also feasibility. So if you don't really know what impact means to your user, put together a list of questions. Talk to your team, talk to your user. If you are unable to actually talk to your user, understand the persona of that user. Who is your user? Give him a name. Try to understand what he's trying to accomplish with your system, not just the functionality. So you need to have a good understanding of the impact to your user and the feasibility. And feasibility, it's probably something that will be easier for our teams, because we know what we can do and what we can't do, what we have available and what we don't have available as far as test environments and test data and other tools that we may need. So the whole idea here is, if there is probably some of the hard ones as far as feasibility goes, these are probably backlogs for your team to work on and improving your environment, your ecosystem. There's a lot of test data and test environment improvements that the teams that I work with have done while looking at feasibility for testing, because even though some of the things that they were evaluating didn't really had that much impact in some cases, the feasibility gave us a good insight on how could we improve our environment, how we could prove what we were doing as far as test data, test integrations, and making sure that we were able to test all the different scenarios needed to test. And that's all I had. I know we still have a couple or 15 to a couple minutes. So I think we can get a couple questions. But I would like to thank you guys for being here today. I have been here on some other occasions. It's always a pleasure to be here. I know it's a lot of information. I know for some of you guys out there, it's probably too disruptive or too difficult to see how you could use that on your teams. But I believe that part of our work as quality coaches or in a coach player mindset, we need to help our developers, our teams, to think in the different ways of actually doing our work. In some cases, we are still trying to do the same thing that we have been doing for the last 20 or plus years, which is looking at the requirement, which we are now calling user stories, and just trying to test every possible scenario. And I like to bring this different kind of at it, where we are trying to prioritize, trying to use something that has been tested on some other groups or in some other areas, so we can use that to help what we are doing as a QA person, as a QA team or a QA domain. So that's kind of the whole idea here, and hopefully you'll be able to apply some of that on your team or with your teams. And if you have any questions, if you have other questions, or if you want to discuss it, some scenario that you have on your team, or some perspective that you want to use with what I shown here today, you can look me up on LinkedIn or on Instagram or Twitter or whatever your preference is. So thank you again, and I think that's all I had.
Great, Rafael. Why don't you hang out here for just a few minutes if you can?
Sure.
And as you said, we're going to encourage everybody to throw some questions out there. In fact, I'm looking at this one here, a little generic over here from Nikki over there. Says, please, I need to know how to create a framework from scratch. Thanks. Well, that's a big ask. I think from what Raphael was speaking about, I mean, he had that slide up there where we had the four things that you're looking for on there. No brainers and big bets, um, and then utilities and what's unwise to do out there. I like that part about unwise, because it's usually people are trying to, like, let's automate everything, let's try and test everything, and there's just some things that they'll say, okay, we're going to put in this order, but it's not going to process till midnight, so your script has to keep running until the next day, and you're like, well, that's not automatable, really feasible, but there
Yeah,
are
or
solutions
or
around
you
it.
have to keep checking for any status. Has it been
Yes,
processed? And the whole idea and the whole idea with the one wise, it's because it's not because you can do it that you should do it, and
yes,
so yeah, and I think to the generic question on the framework, those four groups also applies when you are creating a framework, because it's not because you can do something with a framework that you have to do it. So I like to think of those four groups as something that we can use for pretty much everything, or for every analysis that we are trying to do. So we need to think about what are some things which are unwise, and especially with automation, we like the challenge. We like to prove that it's automatable in a way, but in some cases doesn't mean that we should do it. So if my script needs to wait 12 hours for something to get processed, or if I need to keep checking some other status, or if I need to keep checking integration with a different system, I mean, you could do it. you probably will get an answer if it's working or not. But does it make sense? Is it cost effective? Is it time effective? Because in some cases, if you have a huge effort on trying to automate something, probably you are automating the wrong scenario, or you are automating in a way which doesn't make sense. And in we are all engineers. We like to solve problems, and we'll probably find a way to do it. But again, doesn't mean that you have to do it.
Yeah, in my experience, that example I'm using, what we ended up doing was that we were able to force the queue to get to process whatever we put in there. So our midnight execution happened 10 seconds after our test had submitted some order, and then we could respond back, and then that worked out great. But yeah, like you said,
Exactly. Yeah.
one of the other things I look at is that when someone's asking me, well, we need to verify that this color is correct. I'm like, okay, how much is the company going to? How much money will the company lose if that color is not correct? Don't get too bogged down into the details. Try and keep focused as like you said, the no-brainers. Did the order actually complete? Was the customer sent an email? Did a SMS message get to their phone? Those are the important things to kind of keep track of in there. Um,
Yeah,
and I like,
exactly. Yeah.
and you
Yeah,
also
yeah.
mentioned the utilities out there. Go ahead,
Yep.
Rafael.
No, sorry. I was just gonna say that in some cases, the color it doesn't really make sense because we have like colorblind people out there. So, are you gonna be looking out for every possible different scenario? Probably not. So, I keep saying that we are trying to keep doing the same things, and that applies to testing as we have been doing so far, which is pretty much I need to test colors, for example, or I need to make sure that obviously you have a kind of a standard. You have like the layout of the page and things like that, which are important. But what I like to say is we need to ask the questions. We need to be inquisitive in the sense of, does it make sense for me to test this, and having the utilities and the unwise and things like that, that helps you, right? So that's kind of the idea.
Yeah. Also, when you're talking about the utilities, that's one of the things I've saw when I first started automation 20 years ago. Was the first thing I automated was to click a button, so that enough times that you could fill up the hard drive, and that would take about an hour to do. The manual testers were doing it, and we call it the FNG test. It was the freaking new guy. So whenever the new guy was there, he said, "You get to push the button while we go to lunch." And then
Yeah.
I came in, and I'm like, I can automate that. That's 3 lines of code. That's a click and a loop, and one line to see if the drive is full, and then
Yep.
it'll stop. You guys can do the last three and make sure we didn't blow up the systems along the way. Um,
Yep.
I also think that also gets a little bit into the area of robotic process automation (RPA),
Yep.
where we're not checking to see that it actually works, or we're not looking for defects or anything. We're actually trying to take away the menial processes of day-to-day work, our day-to-day
Exactly.
job.
Yep.
And
Yeah, and I did an automate. I worked in a bank, and at some point they're like, yeah, we need to have somebody which is like the test automation expert or whatever. And since I had some experience with automation, and I knew a little bit about DevOps and automating processes, they were like, yeah, you're the guy. And they had this kind of compliance check or whatever, that they work with a lot of suppliers and things like that. So the whole idea with the supplier is they like did the actual testing. The bank didn't really have like a QA team. The suppliers were doing all the testing. And the idea is that when the supplier was done with the testing for that given project or given sprint, he would have to upload like evidences and update the system to make sure that he passed out the scenarios and things like that. And he would only get money at the end of the month if he actually, uh, adhere to all those compliance items. But all that process of validating if they uploaded the evidences, if they updated their status, and everything that they need to do within the tool was being done manually. So you had like 4 or 5 people that were doing that. And it was really funny because at some point they didn't really got concerned about checking. They just like, yeah, they will do it. And at some point there was some compliance guy or group that came in and said, okay, I'm gonna check this project. And I think they got 3 or 4 from 5, and they pretty much unupdated. They didn't have all the necessary files and all the necessary items that they needed. So they said, now we're just gonna pay you if you do all that. But they were doing that manually. So after like 3 weeks, they had like a huge backlog, and they were not they were becoming the problem because they wouldn't be able to do it. So I got a macro, like a VBA, and I put it together because they were working with a system that had like APIs and integration with Excel, and I automated that process because that process was a no-brainer. That process was something that we needed to do regardless of, it's like basic stuff. You need to make sure that and it had like a set of checks that you could do. So we use that to kind of understand, and there were other actions or activities that they were doing within that process, which were either unwise or utilities. They didn't add too much to the main process. So I was like, no, I'll give you the responses. I'll give you like green or red, saying this one is okay and it's not okay. And then they had a second step, which it was actually to go to a different system and kind of click a button saying, okay, this is passed or this is approved. But the system didn't have too much integration. It was hard to automate that process. So I said, I'll make sure that I clean up your backlog and give you all the answers, but you need somebody to actually go in there and say, okay, this this batch is approved, this batch is not approved. And they did I think they had like 50 to 80 items and projects to evaluate, which they were taking forever. And I did that like in 1 hour and a half of an automated process. And then they just in with the approval system, they could like use filters. So they pretty much got an output from what I automated, and they approved everything that needed to be approved, or rejected everything that needed to be rejected. But that's a good example of that process was a no-brainer. The approval process on that scenario was something either unwise or a little bit of utility that I could try to do it, but the effort to do it would be, you know, huge. It would be difficult and it wouldn't have that much of impact because the pain point was resolved.
Yeah, that's good. That's good. What I'm actually doing right now for guaranteed rate is that for our testers, our manual testers, we have to create loans and all sorts of different types of loans. And I've created a loan generation tool. Now, for a manual tester to do it and go through about 50 pages of questions, it takes about 30 minutes. And we can generate one of those loans in about 2 minutes. But now it's a competition between me and the API guy who says I can do it in 10 seconds. Like, okay, bring it on. We'll do it. We'll see how we can do it.
Yeah, yeah,
But
yeah.
one of the other things we had to do was we're saying, well, basically the developers do get a benefit from this, but the manual testers want to do it, but they don't want to install JavaScript and an IDE and learn how to execute this stuff. And I said, well, okay, we can set this up so you can just go to Jenkins and just type in what type of loan you want. And then Jenkins goes and
Awesome.
runs it off,
Yep.
kicks it off. And
Yeah,
then it
because
also reports back to Slack and tells them what the information is about what they did. So it's like, great, cool. I don't have to do this. And it makes my day go faster.
and he just wants to have a loan. He doesn't care what the process. He's not actually testing the loan functionality, at least on that example. So I presented I think last year or the year before here, a talk about platforms and how to create platforms for QA teams and dev teams in general. And one of the items is exactly like you said. I need to do something which is not entirely my focus. I mean, I'm not a loan generator. I'm not a, in this case, I'm not a test data generator. I'm concerned about testing a functionality, which
Yeah.
by accident or it needs a prerequisite of having a loan set up in my user in my system. So it really doesn't make sense or doesn't change my day if it's I have like a process in the background, if I have like three buttons that do all that. I just want a way to just say, okay, I need a loan based on these parameters, and I don't need to go through these different screens or this different process. And when I was working with a bank in the past, where we created like a test data portal for them. So the whole idea is we we start mapping the different APIs and things that were actually used in production. So we said, okay, you want to have a credit card approved. we know that it needs those APIs, and then we created this API of APIs. So we created like a approved credit card API, and that triggered the 3 or 4 other APIs that a tester or a developer would need to actually, okay, this is the flow, the entire flow that something needs to go through to get approved. Or even to the funniest scenario was that they didn't really knew how to add money to the bank accounts. So I need to do a payment, for example. I need to have money on my test account, and they were like, no, this is in the mainframe. The tester needs to manually go into the mainframe and navigate to these screens, and they will go to this place, and then he will add money on this field. So first, I actually automated the mainframe. I found that one of those mainframe interaction tools or whatever, it had an option where you could leave a process running on a machine, and it would give you an API. And basically it was an API from the for the tool. So you could say, click this, navigate this, tab this field, or type this information, and it would access it would open a connection to the mainframe and automate execute those actions that you were looking for. And we started adding money to all the task accounts, and afterwards we actually said, okay, but if I found out which API I needs to use to transfer money is a way that I can add money to an account. So we added that to our platform, and we use some of the process here of prioritization to kind of say, okay, this functionality is a no-brainer. This function this test data generation is an utility. They probably can do it. We can probably do it in the future, but they don't have too much of an impact for our user, which is in this case were QA testers and QA people and some of the developers. So your customer can change. In some cases, you are doing something for the QA team or the developers. In some cases, you are actually thinking about the actual customer who is doing something on your system. So
One of the things I usually say is that in test automation, the actual customer is me. I'm the guy who's the customer. My boss is a beneficiary. I do try and kind of warn people, because sometimes they come over and I look at all this output that I'm spitting out that says, here's the whole process that I want. And they're like, too much signal to noise. Get rid of that. And I'm like, but
yeah.
this is making my debugging so much easier. I really can't do that. But you know, there's some other suggestion you got. Well, this highlighting over here, that's awful. Like, no, that tells me I got the right element when I clicked on it. So
Yeah, yeah,
it's,
yeah.
it's good. Yeah. So I get your point there on that. Definitely. Definitely. I don't see any other questions going up there. We did get a thumbs up there from I'm looking at Calcutta Diver. Uh, I'm stumbling over these online names here. Thank you. I'm glad he got some good information out of that. Nikki says she's new to automation testing. Nikki, I'm actually kind of curious. Before we go on to our next speaker, what tool, if you have a chance to type in there, are you looking at using? Everybody talks about Selenium. I know I've worked with WebDriver IO. Rafael, what's your tool that you like?
We are mostly Selenium, a little bit of a WebDriver IO. I have worked with teams in the past which are using Cypress, but the whole thing I have with Cypress right now is that they think they can use Cypress for everything, from web testing to API testing. So just be careful with that. It's a good tool if you use it right, as any other tool. But I have heard a lot about Cypress, robots, which is another one as well. But most of the teams that I have been working on, they are using either Selenium or WebDriver IO, mostly because, especially WebDriver IO, because in some cases you have visual testing available with some other well that you can compare images and see things like layout and things like that.
Okay.
So, yep.
Great info on that. So Rafael, I really appreciate all your time here and all your input. I think everybody learned a lot of cool stuff over there, and I thank you for your time.
Thanks, guys. And Paul, I'll look forward to your talk next month. See ya.
You got it. Bye. All right, everybody. So that was our first hour. That was fantastic over here. And coming up next, we've got Péter Földházi. And he confirmed I said that correctly. Maybe I've done it twice in a row here. That's cool. Peter, I can see, is already online over there.
Yes,
Peter
I
is a
am.
lead software test engineer at EPM Systems, and he's going to be talking about actually, I think, something very near and dear to my heart, which is the flow model versus the page object model, which is something I've been struggling with for a couple of years myself. I don't know the flow model, but I suspect it's going to be similar to something I've done in my past. So, with that said, Peter, take it away.
All right. Thank you very much, Paul. And yes, you pronounced my name correctly again. So kudos to that. I know that it's with all those accents, it's a little bit more difficult. So appreciate that. Yeah. And let me actually start sharing my screen just a moment.
Cool.
And let me know once you can see it. It should be bringing up now.
Yes. Yep, I can
Great.
see
Yeah,
it.
I can see that. Yeah, so thanks again, Paul. And yeah, let me actually start it. So, as Paul already introduced me, I'm Péter Földházi Jr., and I've been working for EPAM actually almost exactly 10 years now. Actually, I celebrated my 10th year anniversary last Saturday. So, yeah, now in the two digits being together with EPAM. And so I'm a quality architect there. Basically, what that means, I'm a test automation and testing consultant, and I help start projects, kick off with testing and test automation, or if there are projects where with new clients that are struggling with their quality, then I can jump in and help them assess the current situation and improve their quality overall. So that's basically what I'm doing right now in EPAM. But my background was test automation. So for 8 years, I had been doing test automation mostly on all levels of the testing pyramid, doing it on mobiles, web, and desktop as well. So it was fun doing a lot of coding and some manual testing as well. And so what I'm going to talk about is hopefully going to be useful for you, Nikki, and for everybody else as well. So I saw that you are looking for ideas how you can start building frameworks from scratch. So I'm not going to answer that like fully. Of course, that's like a big topic, and probably you need to listen to multiple different topics to be able to really understand how you can design the architecture of a framework and how you can implement it. And actually, I have another talk, the trial your testing architecture. I guess that's more helpful in the in the sense of giving you an idea how you should organize your libraries and test cases to make sure that you can start from scratch and everybody else can reuse your components. But as design patterns are basically helping you in designing your solutions and test automation solutions as well. I'm sure that page object, flow model, and all the other design patterns that I'm going to be talking about will help you in your journey. Okay, so that said, let's get started. So the first topic is going to be about design patterns in general. And as test automation is partially testing and partially development work, I think it's very important that people who are doing test automation, even if they are test automation engineers, developers, or testers, or whatever positions they are in, they still need to be aware of some of the design patterns and the design principles. And so when people talk about design patterns, most people talk about the Gang of Four design patterns. That's what they think about first, or that I think that's what people should think about first, because those were published in 1994, and we are still leveraging those design patterns, and it's really useful. And actually, my favorite one is the facet pattern. And one of the reasons is because it's actually used in all of the test automation specific design patterns that I'm going to show soon. And what is it exactly? So the facet pattern helps you hide implementation details and basically provides you services called facets that your other libraries are going to use. So in this example, I have a login flow. A login flow is going to use the facets of the main page, the login page, and the profile page. So I'm already pointing to the page objects, which I'm going to go into more details later on. So the flow model is going to leverage those facets. And the facets of the login flow are going to be leveraged in these test cases over here, and probably in many others as well. So we basically are not really interested in the implementation details. You just want to reuse certain services that these facets are providing. Of course, you might be the one who implemented it, and in that sense, you are interested in. But when you are using them, you just want one line instead of 10, 20, or how many lines you have behind it. Okay, so I mentioned that test automation specific design patterns are leveraging the facet pattern. The first and most popular and most known one is the page object, which was invented by Simon Stewart and his co-workers sometime at the beginning of the 2000s. And so this is something that if you go and interview to a company for a test automation role, I think in almost all of the interviews or most of the interviews, this is going to be a question. What is a page object, or how do you implement a page object? So there's probably going to be a question about it. So it's very important for test automation engineers to learn about the page object and to actually use it in their work. And so the second one that was invented by Anthony Marciano a couple of years later, around 2007 or 8, was the screenplay pattern, which is actually leveraged in Serenity BDD. And so they had a couple of issues with the page object that they wanted to address. I'm going to talk about these issues a little bit later. And so that's why and how they came up with the screenplay pattern. So next up is the flow model, which I invented 9 years ago, actually more than 9 years ago. So it's been time now. And so I'm going to share more details about it a little bit later. And the last one that I mentioned here is the UI objects, which was invented by my ex-colleague, Roman Yevlev. And so how these are different from each other, high level, is that the page object focuses on how you organize your pages. The screenplay focuses on how you organize your users. The flow model focuses on the user actions. And the UI objects focuses on how you operate the pages. Okay, so that's in a nutshell about design patterns. And let me just have a sneak peek to whether there were any questions so far or not, but I don't see any. So let me hop back to the presentation. Okay, so next topic is the page objects. And so for me to be able to really show what the page objects are and why is it useful, let me first show you an unstructured script. So what do you think when you look at this piece or pieces of code? Probably at first you don't know what exactly this is. Eventually you will figure out that probably this is a test case and this is a successful login scenario. So, but you need a couple of maybe a couple of minutes to really figure out what's going on, what are the different steps that you are taking. So this is not really intuitive when you look at it. So of course, it's not an ideal scenario, and hopefully nobody uses that in a long-term automation project. But for POCs or just getting started on your automation journey, it's fine to have such a test script, just one or maybe two, but not too many more. And make sure that you start leveraging page objects or flow models later on. So yep, this is how my face looks like when I see people still using unstructured scripting in their serious test automation solutions. Okay, so how does the page object help you with that? So the page object is basically It's providing models, class files for each of the pages that you're going to interact with. And each of these class files are going to write down the elements that you're going to interact with and how you can locate them. It's simple as that. And you can have like all sorts of different buttons, speakers, images, text fields, and so on that you are going to test. You're going to check whether they are there, you want to click on it, or you want to type a text and proceed sending the text and see what the reaction is going to be from the website or the mobile application. So that's what the page model is really about in a nutshell. And so how it started, as I mentioned earlier, it was invented around the beginning of the 2000s. And so the idea came from the web driver, I mean, the Windows driver, window driver that came from Martin Fowler. Actually, Simon Stewart and Martin Fowler worked in the same company at the time, and that's how Martin was able to influence Simon and his colleagues. And the first speech about the WebDriver and the page object was in 2007. And that's basically the time when Selenium was born and became public. Okay. And before I move on with a little bit more about the page objects, it's very important for me to talk about solid principles. So just like design patterns, design principles are very important as well for developers and test automation engineers alike. For example, OP principles and the SLOID principles. Typically, when I interview people or we have a promotional assessment for people who want to grow to higher level of test automation, then we typically ask this from seniors or more likely from lead engineers. So I don't think that it's necessarily important for juniors or experienced test automation engineers to know that these principles, but they are actually really useful. So it's good to read up on them. I'm only going to be talking about the first one, the single responsibility. So on the left side, you can see a bunch of shapes in one pack. So that represents one class file, which is going to describe you how you can create and interact with these different shapes, such as the triangle or rectangle. And so why I have them in these one batch and like in one class file is because this is actually an anti-pattern, and this is not really recommended. And this is the example that if you want to make any changes in the rectangle, you are going to make that change in that one big class file. So what's going to happen if you didn't design your class file correctly, or when you make the change, you are not careful enough, you might introduce changes to the other shapes as well, not just to the triangle. And you might actually introduce bugs this way. And that's one of the reasons why it's not good to pack everything in one class file. The other reason is because it's going to start growing bigger and bigger, and it might be a couple of hundreds of lines of code, or maybe even thousands of lines of code. Unfortunately, we have seen many such examples in public repositories, and it can be a nightmare to work in such class files. So because of that, Uncle Bob recommended to separate the concerns, and instead of packing everything in one class file, why not have three different class files for these three different shapes? They can still inherit a shape class file to make sure that there are some commonalities between them. But when you want to make a change just in the rectangle, then you're going to change just that class file. This way, you are making sure you're never going to touch the other shapes at all when you want to make a change in just one of them. So, and of course, they are going to be much smaller, much more easy. It's going to be easier to read them and to maintain them So the benefits are there, but there's still one question. So how do you, of course, in this example, it's very simple. But when you think about your examples in your production code, in your test code, how do you determine the different responsibilities? It's not always this trivial. And so Uncle Bob was thinking about it for years, how to best describe it. And I think it was somewhere around 2008 or maybe later when he came up with a very good explanation. And what he said is that you need to think about from who, from where the request for change comes if you need to make a change in your class file. And that said, let's think about the page objects and the different responsibilities and who are responsible for these different aspects of the page objects. So we know that page objects typically include locators, which you're using to locate the elements. So you store the elements as well. You also have the actions in those page models and potentially concatenated actions, which are the user flows. So I will give you 30 seconds to think about who could be the responsible people. And don't be shy, write it to the comments. I'm really curious what you think. I don't see any comments yet, but if you have any opinions, any ideas, please share it with us. All right, I think I gave enough time, so let me share my version. So for the locators and elements, typically it's the developers because they are the ones who build the application. So if there's a change in the DOM, then the locators are changing, and because of that, the elements are changing. So anything regarding the locators and elements, any change is going to come from the developers. So they are the responsible people. For the actions and user flows, of course, it depends on your company culture and especially the project setup. But if you, for example, you are leveraging BDD and like actual BDD where the scenarios come from the business owners, then you could say that the actions and the user flows are coming from the business. But most typically what we see in like almost all of the cases, it's actually the testers who provide the test cases and the actual test steps and then user journeys. So I would say that typically for the actions and user flows, it's the testers. So that means that there are at least two different source of people or group of people from who change may come when you need to make a change in your page models. So that means that there are too many responsibilities and it breaks the single responsibility. So that's basically the biggest concern of people who brought this up, that there's necessity for making change in the page objects. That's why the um, Serenity team also came up with their solution, and they also say that it breaks the open closed. I don't consider that actually that big of an issue, or I'm not fully agreeing there. But that's okay. I don't agree with the part where people say that it breaks the Yagni principle, because the Yagni principle means that you ain't gonna need it, which means you're going to, because there are people who create really big page models. They store all the locators, all the elements of each of the pages, but they are not actually exercising all of them in their test cases. But actually, is that the issue with the page object model? I don't think so, because the page object model just tells you how you can build your class files for each of these pages that you're going to write tests for. But who is responsible for defining which elements you're going to interact with? it's those who are writing those page models. So actually, it's you who is responsible for that. If you are not following the Yagni principle, it's you who is breaking it. It's not the page object. And lastly, it's not like closely connected, but the page factory is not recommended anymore. Well, it's closely related to page objects, but it's not the page object itself. But it's something that I see that people are leveraging it, and maybe in small projects it's not a big concern, but on bigger projects I have seen people coming back from using the page factory and instead just building their own. Okay, so I will pause here a little bit and check whether there are any questions. But I don't see any questions yet. So in case you have any questions, feel free to ask them. I'm very happy to answer them during these like little breaks. Right, so let me go back to the presentation and talk about the flow model pattern. First, focusing on UI test automation. So I told you that the page object is breaking the single responsibility. And so how can you fix that? I will give you a very good example for that, a very simple one. So on the left side and on the right side, you'd see the two similar but a little bit different houses. So on the left side, that represents the page object. So there's a facet here, and this facet involves all pages, user actions, and everything else. So everything is stored here. Whereas on the right side, on which represents the flow model pattern, now you have two levels of facets. So you have the pages here, the smaller ones. You have a bigger one above them, which represents the user actions and user flows, which are going to leverage all the pages and the widgets. So how does that look like in practice? Before going into those details, let me show you what a human state machine diagram is, because that's going to help you understand the flow model pattern a little bit more easily. So human state machine diagram has basically states and transitions. So in this example, I have a soda machine, and what I want to do is I check the list of drinks, I select the drink. So I get from one state to another through a transition. So now I'm there at the payment. I insert the card, I get to the confirmation, and also I get my soda. So that's great. So this is a simple state machine diagram, and this is basically how they look like. Now the reason why I mentioned it, because the flow model is like, if you want to show it with diagrams, then it's basically UML state machine diagram. So you have all sorts of different screens or pages, and these are the pages that you're going to interact with. So you have your interactions, for example, the click actions. So you click on the login button, you're on the main screen, you get to the login screen through clicking on the login button. Then you type in your credentials, you remain on the login screen because whatever you type in, it just remains there. Once you click on the continue button, and if you gave proper credentials, you get to the profile screen. Then you can do whatever you want, edit your profile, or if it's, for example, a bank wealth management application, you can check your portfolio, or if you can make transactions or buy anything, you can do that there. Once you want to log out, you just click on the logout button and you get to the main screen again. So that's how it's different from the page model, because the page models include all the actions inside this page models. So the screens and the actions are together. So you don't really get to see where you're going from. You see where you are, you can see what you're doing, and you just get somewhere. In the flow model, you see how you get from one screen to another. So what's actually going on in your entire system. So giving you a little bit, a slightly bit more complex example, let's go with an Android example. let's say that you're on main screen, you want to, again, log in. So it's the same scenario, but now you have a toolbar widget. So on the top, in the toolbar, you find the menu button. So you have that menu widget there. So what is a widget? A widget is an element that can be represented on multiple different pages. So typically, like for example, a login widget. In this example, actually, I don't have a login widget. I have a separate login screen. But here, for example, menu button, the hamburger button is going to be there on all pages. But it's not, so because of that, you still need to be able to interact with it on each of the pages. But it's not dedicated to just one page. So you need to handle it as a separate class file. So that's what widgets are. So you have a toolbar widget, you have a menu widget. So when you tap the slide menu button on the toolbar widget, which is on the main screen right now because you are on the main screen, then the menu widget opens up. That's where you tap the login button, so you get to the login screen. You do your login, you click on the login button, you get to the profile screen, you do whatever you want inside the application. Once you tap out the login button, logout button, which is again on the toolbar, or you could have it in the menu widget as well. In this example, it's in the toolbar. Then you get to the main screen again, logged out. Okay. And so let me actually check whether there are any questions, but I don't see anything. In case you have any questions, if anything is unclear, just make sure to like speak up, like write your questions, and I'm very happy to have some more, like provide some more insights. Okay, so next up, how does so where do you put these flow models? So I'm showing you a tri-layer model where you have your test scripts on the top layer, you have your app independent libraries on the bottom, and in between you have your business logic, basically all the application dependent libraries. And that's where you are going to have your flow models and your page models as well. So I call them structure models here just to distinguish them from page models, but they are basically still page models without all the user actions and user flows. And yeah, that's exactly what I mentioned here. So you have all the flow models and structure models in the business logic. Okay, let me give you some examples. So the first example is going to go along this tri-layer example and the login example. So I'm leveraging a tri-layer architecture. So I have a base screen, base page that all these screen models are going to leverage. I have a user action, which the base flow is going to leverage, and then the login flow is going to inherit all what's inside the base flow. Okay, and basically the login flow is going to leverage all the facets of these screen models and widget models, and the login test is going to leverage everything from the login flow, so all the facets that the login flow provides. Okay. Going onwards, how does it look like in coding? So this is going to be an Android example, and you might remember these couple of lines of code from a couple of slides earlier, where I showed the unstructured scripting example. So of course, this is not so nicely looking, and it's not so maintainable. So you have to do something in order to make it work in the long term. So what do you do first? So your first iteration should be creating your page models. So you create your page models, and what you do, you create your elements here, and all the like username, login button, password, show password, whatever else you want to store, whatever you are going to interact with in your test cases. So next up, what you're going to do is using them in your test script. So now your tests are going to look much different. So the part where I'm leveraging these previously shown uh, elements are going to look like this. So now it's a little bit more easily understandable. So when you look at it, now you know where you are. Remember, that the flow model is basically a UML state machine diagram. So now you have the state part, where you are at, which page you are interacting with, and which element you are interacting with. So you already have that now, the what part. Okay, next up, you want to know what you are doing, so where you are going. And so for this, you should create your flow models, one or a bunch of different flow models as well. In this example, I'm only showing you one flow model, the flow login flow. So you have different methods here that are actions, user actions, and you can see that they can have like one or two or even more lines of code. So you can concatenate steps. You can have the actions, and you should have these actions because when you do a certain action, you also want to validate what happens. Okay, of course, that's a deeper discussion as well, but in general, that's what my recommendation is. So how is your test going to look like after this? So now what you see in your test, you see what user flow you are going through. So you know what you are doing. You are logging in. Whether that's a successful one or not, of course, that's something that you have to still figure out. But when you look at it here, you see that you type your username, password, you finish your login, you want to check whether you logged in as Darth Vader. So probably that's a successful scenario. So now you can do a lot of different things. In this case, just simply logging out. And how does it compare to all the other implementations? So the unstructured is much longer and not so readable. You don't know where you are and where you are going. And on the page model, actually here you already know where you are, which elements you're going to interact with. So it's already maintainable, readable. So that's pretty awesome. But in the login test, you know what you are doing exactly. So you know that what test you are executing here. And that is the power of the flow model, because ultimately, when you are doing test automation, it's still a testing activity. So you have to think with a tester's mindset. And in my opinion, if you're doing a test automation activity, you are part tester, part developer, and that's how you become a test automation engineer. So, and that's why 9 years ago I came up with the flow model, because I wanted to understand my test cases, even if I came back to those test cases a couple of weeks or couple of months, or maybe a year later, I was still able to understand what exactly was going on in my tests. If I wanted to understand where am I just always went into the implementation and checked which page model it's interacting with and which element of those pages. And if I wanted to make any changes, let's say the DOM changed, I needed to make an update, or user flow changed, and I just went into those given page models or flow models where the change happened. So everything is easy to maintain because of that. Not just the pages anymore, but actions and the user flows as well. So uh, any questions to what I have shared so far? I'll give you a little bit of time to come up with questions. If not, then I can continue with the presentation, and you can post your questions in the meantime. And we can come back to those questions once finish the last part of the presentation. So let me do that. So uh, in the next section, I will focus more on the end-to-end testing and API. So not focusing on the UI at all, but of course, you could still include UIs as well. So I wrote here, no UI, no screen, and page models. So in this example, that's what I'm doing. Of course, in end-to-end testing, you could have a combination of UI, API, and DB testing, and so on. So what am I going to do here? So I'm going to make a little bit of change of how the flow model looks like. So previously, we had flow models and structure models, right? So we had these structure models because we had a graphical user interface to interact with. But if you don't have a graphical user interface, but you do have APIs to interact with, then you should have utility classes where you describe how you can interact with those APIs. So let me give you one example. And in this example, uh, let's think about someone with a bank card, let's say with a credit card, who has an account at a given financial institution and wants to make a transaction, and either accidentally gets suspended or for whatever reason, maybe someone stole that card or just couldn't find that card, so gets the card suspended. After that, wants to make a transaction. So we want to validate that this transaction doesn't go through, but then finds the card, and let's see whether we can suspend that card and do a transaction after that. So how does that look like? Now, in this example, you see we are leveraging more than just one flow model. So account flow, suspension flow, transaction flow, again the suspension, again the transaction, and again the account flow. So three different flow models. And again, it's very easy to understand what's going on. So you know that you have a user, you want to log in with that and validate that it has a valid card. Okay, so it has a valid card. That's cool. Let's suspend that card because if there's a valid card, you can suspend it. And then let's check whether that suspension went through or not. After that, try to make a transaction, validate that it's suspended and that you couldn't make a transaction, so that it's denied. After that, let's try to unsuspend the card, validate that it happened, and do that transaction, the same transaction again, and let's hope that it's a successful one now, and whether the balance decreased. Okay, so this is very, so when you look at this test case, you know exactly all the test steps that are happening here. Still, you might want to concatenate some of the steps, especially validations, because you don't want to detail all of them in your test script, and especially if you reuse them a couple of times. For example, validating the successful transaction, or for example, validating that the suspension went through. So where are you going to validate the suspension? You're going to validate the response itself and like the response code, the response body. You're going to validate the database as well, and you're going to check through the logs. In this example, I chose Splunk for that. So you are going to check those logs as well, whether the actual suspension went through. So you still might concatenate a couple of different steps here. When you look at the test case itself, you only care about validating the suspension. That's what you're doing. But what exactly you are doing beneath that or like within that can be stored inside a facet. Okay. So to sum it up, basically the flow model is not bringing the single responsibility. It leverages facet patterns just like all the other test automation specific design patterns, but it actually leverages a double facet. That's how you can you can follow the single responsibility and make your code easier to read and easier to maintain as well. So because of that, it's easier for newcomers to ramp up. This is actually what happened that was at the end of 2014 when I had a team of junior Android and iOS developers. So they just went through a mentoring program, and before starting a project as developers. They wanted to learn about test automation. They wanted to improve there as well. So they joined my team as test automation engineers. And even though they were fresh juniors, they were able to be productive already on the second day. So first day we had uh, I had one-on-ones with them. Next day they already produced test cases following the flow model pattern, and everything was maintainable. So it's really, really quick to learn it. And it's also the good thing is that you can leverage it not just in UI testing, but in all sorts of different other testing end-to-end scenarios where you leverage APIs or even database and other testing as well. The downside of the flow model pattern is that you need experience. So when you do it for the first time, and if you are not a tester, you don't have a tester's background, and you don't have the knowledge, the domain knowledge of that product that you're going to test, it's going to be more difficult for you. On the other hand, if there's someone in your team who does have the domain knowledge, and let's hope that there is, otherwise it's overall the quality is going to be low if there are no people who understand what the product is. So yeah, let's hope that there's at least one person who can help you define the different flow models, and together you can design it. And the first couple of times you're going to do it, it's going to take a little bit more for time for you to design it. But once you get the gist of how to create flow models, next time you are working on a new project, it's going to be much easier for you and much quicker for you to leverage flow models. And that's it. Thank you very much for joining this session and listening to my presentation. I hope that you will be able to take away something, and the next day you're going to be able to leverage it in your work. And if you have any questions, please write it in the chat. I'm very happy to answer all the questions that you may have. And if you want to read more about the flow model, I'm actually going to write a couple of articles about it and we'll publish it on my website. And I plan to publish articles about other test automation related topics as well. You can find me on Twitter, LinkedIn, and all my videos are on YouTube. And I would like to thank Sapotec for organizing this online meetup. And I guess someone is waiting me over on the other line. So that's all. Thank you.
Looks like you do have a question out there. We've got one from Alex Sidyakin about page objects or app actions in Cypress. I'm not sure how much you know about Cypress. It's a little not quite. I can't speak to it on that. So, what's if there's anything any answer you can give on that?
To be honest, I'm a little bit confused on the question itself. So, if you could clarify, Alex, whether you mean because I guess you mean which one is more preferred, the page objects or the app actions in Cypress. I won't be able to answer that question because I need clarification. But to be honest, from my experience, so I've been using Selenium. Okay, thanks, Alex, for the clarification. So I think if you're leveraging Cypress, probably it's better for you to go with app actions, right? Because that's what's being leveraged there. So it's probably going to be easier for you to go with that. In general, I think the page objects is pretty nice. As you could see, it can be improved. And so if you follow the flow model, you already have the page models. You just wrap the flow model around it. So, and you are going to take the responsibilities, part of the responsibility of the page objects. So if you follow that, I think you're going to have more powerful page objects because you only are going to focus on the locators and the web elements and nothing else. So I hope that probably it just partially answers your question, but I hope that it answers it.
We just a reminder, we've got about 15 minutes left. So if you've got questions on there, please write them in there. During that time, I actually took a few notes while I was watching this. I wanted to bring up something that Peter actually mentioned that not a lot of people in automation notice or know about automation, which he mentioned that tri-layer architecture. And most people think, well, it's just a test case and it's all record and playback and it's all that. At least the freshers do. 3 layers is always what I'm always looking for. Your test cases, your business rules that you have in the middle, which is what processes are you going through, and then the last layer where you're supporting everything. So in my case, I'm always writing wrappers for select, enter, and click, and then putting in stuff in there that kind of makes the framework more reliable as it's interacting with elements. And that's really a good layer. I think of it like a 3-layer cake, and when you're looking at stuff. And,
Oh yeah.
it just breaks down at least 3 layers. In some cases, if you go to Cucumber, you go to 4 layers. I don't like going that far. I'm willing. Cucumber's great. In my project right now, I don't have any Cucumber. I keep it to 3 layers, and it's exactly as Peter's got out there, where you're breaking it out into the different pages and states in that flow model.
Yeah.
One of the things, yeah, go ahead.
Just one more thing to add to that. Actually, I had a not a previous, but a previous version where I actually had a couple of different topics, like the flow model, the tri-layer testing architecture, and test case selection. I think it was these 3 topics in one presentation, and that was in 2015. And in that version, I represented the flow model. Like I have these for each of the chapters. I have a picture about different rock formations, and in that one I had a layered cake, and it looked, I think, really awesome. The only thing was that when I presented that one the first time, then it was lunchtime for everybody.
Oh,
Yeah, and they were right to be like, oh, it looks so nice, but it's so painful to look at it while being hungry. So
it's called lunch and learn, people. We have lunch. You bring your lunch. You sit there and watch the whole thing. Oh, it's good. Yeah, actually, I did the same thing. With mine's actually an upside down layer cake. Things are kind of getting smaller because they're all using things at the bottom layers and then coming back up to the test. Let me think. What was some of the other stuff that you had in there that was good? I'm actually working with a flow that I've had recently that. Hang on a sec. Before I say that, we had a question coming in from Nikki over here. I know that's not related to this presentation, but I really wanted to ask, what is the main difference between test cases and a test plan? Peter, you want to take that?
Okay, I'm guessing that this question comes because of QC. That's my assumption. But it's a little bit deeper topic again. There are big differences. So first of all, what is a test case? A test case is, if you want to describe it the simplest way, it's basically the steps. It describes the steps that you're going to take to validate a certain functionality or set of functionalities. So it can be a simple atomic test case where you have only one test step. What you have a precondition, you have an action, and then you have a post-condition, which is basically the validation. This is exactly what we see in the Gherkin language as well. Given, when, then. That's the given is the precondition, the when is the action, and the then is the assertion, validation, however you may call it. But okay, so that's one way to describe it. Or you could have, like, just like in the flow model, you have a bunch of different test steps. Some of them are simple ones, some of them are complex ones, and you concatenate them, and you have a long user journey which helps you validate not just one functionality, but like a whole set of functionality. And this way you can have a bigger coverage of validation for your application or for your service. That's how you can create test cases. Now, test plan. I'm guessing that the question comes in because in certain test management tools, you can select a test plan and decide which test cases and test suites you are going to run. So that's my assumption that the test plan that you are referring to is that test plan. So basically, the test plan is the plan for that release where you are going to do your release testing and you are selecting which test cases you are going to test. That is all. On the other hand, and that's again, I think for if you go for an interview, uh, this is something that especially for I think functional testers, manual testers, or especially for test managers, this is a common question. What is the difference between the different kind of test plans? Or what is a test plan? Or what is the difference between a test plan and a test strategy? So when I think about test plans, I don't like to think about it as the plan for that release. So there can be a release test plan. I like to think about it more of like a project test plan because with Agile, we started moving away from that waterfall way of thinking. In waterfall, for what you did, you prepared for really long, robust testing, and you might have had like different stages, which took not a couple of days, probably a couple of weeks to go through. Now in Agile, and especially with DevOps being more prominent, what we are trying to aim for is decreasing the time spent on testing and still being able to cover as much as possible. Obviously, that's a pretty tough situation for us testers. So when we create a test plan, what we try to focus on is what we are going to test. Well, so what is the product? Why we are testing it, how we are testing it, that's the strategy part. It could be project specific or better to have it as organization level strategy. Again, that's a different discussion. And then when are you are going to test and where? And yeah, so if you can get to a point where all of your tests or most of your testing is automated and it's in the pipeline, in a single pipeline with your application or service, then basically your test plan is going to be a really small document. And you're basically describing how you integrate into the pipeline and what are the environments that you are going to test against. And some more questions are going to be answered there, but this is how it should look like. And I know that I gave a little bit wider answer to this question probably, but I hope that this amount of information was useful.
Yeah, I think you hit it right on the nail there. Nikki's actually asking, the test plan. I had expected us to actually throw in there, the test strategy. Peter, you're totally right on there. The way I should think about it is that, the test plan is your scope, what you're going to be testing, what areas, what you need, what kind of data, defining what the process is going to be. When you get to the actual test strategy, it's how you're going to do it. What's our in my case, I'm looking at in coding standards to how we're going to put this together. It also brings up a point that I was thinking about, and Nikki says thank you. That's great.
Sure.
One of the current challenges I've got I had was I think I mentioned the first half of this is that at my current job I'm actually creating loans, mortgage loans, and there's a flow that basically goes through. What kind of, is this a refi? Is this a new one? Are you buying on as your own on your own, or do you have somebody else with you? And then the branches just become incredible different logarithmic branches of the whole thing, and it's hard to build a test case out of that. Or so many of these. So what I've because this path, some of the pages you get to, depending on what you select on one page, the next page may not be the same, may not be what you expect. So what I've been doing myself recently is I've got basically a loop that says, all right, process whatever page I'm on, click the next button. What page am I on? Process that. And it loops and basically navigates its way through the whole thing to the end. So if a page is missing, doesn't matter. If but the only thing that breaks is when a brand new page is introduced, and then I've got a little bit of maintenance versus a test case where we're going from top to bottom, and then all of a sudden you got a new page in the middle, and I got to go fix that, or one got removed, and then you got to say, okay, ignore this. So that's the flow is really a really big thing to consider on when we're doing that, and I think Peter did a great job on explaining his process on that. Definitely will come in handy on that. We still have about 5 more minutes, and let's see if there's other questions or anything else I can throw in there and ask you. Well, I tell you what, at the very beginning, uh, uh, you're welcome, Nikki. At the very beginning, you actually talked about, we have the page object model, page factory, which is kind of going away. Can you give us some tips on the big challenge where our elements are changed by developers? They make slight tweaks to what's the element is, and our locators. What can we do to kind of reduce the maintenance on our locators to handle that?
Yeah, so obviously, so page models helps in the fact that if you need to change it, you only have to change it at one place. But that's still not enough, obviously, because if the DOM changes frequently, now you can do two things. One of them is to find another locator strategy that might be more stable. So typically, one mistake that we can see is that people come with like very like a static XPath, and then they they are surprised that every day they have to change it, or even every like couple of times the same day. Obviously, if you choose a locator, which is a static locator, instead of trying to just go closer to what exactly is the element that you want to interact with, um, then it's going to be unstable. On the other hand, sometimes even that is not enough. And what can happen is some sort of machine learning solution. So, for example, the Selenium, if you search for Selenium.io, provides such a solution. So that's an open source framework based on Selenium. And so why is it Selenium? Is because it's a Selenium which itself. So if there are any changes in the DOM, it's able to detect the change that it didn't, so it's not going to pass. So it tries to find an alternative that is very close to that original locator and tries to execute that part with this new locator. And if that doesn't work, then it will still try other alternatives. And there's kind of a chance of which one is going to be like more likely to pass. So that's basically how it works. So that's what you can do.
That sounds great. Sounds a lot like what I've been doing for 15 years. Somebody owes me some internet money. I do the same thing. One of the big recommendations I tell people when they were doing this, creating locators, and what Peter described, his very first example is when you see something that says something like div/div/div3 div/a, and you get a link and then that path gets broken. It's horrible. The thing that I tell my team members is when you're writing your locators, don't make them exact. Like, don't say, if you're looking for add to cart, don't just say text parentheses equals quote add to cart. Put the word cart in there, and then just say, okay, let's see if we can say text contains cart, and I put in a little code in there that says, okay, hopefully we only found one match on that. If it's like 2 or 3, then very similar to what Peter was describing with Selenium. It goes through and says, let's try a couple of different ways to try and find a single match of an element that's out there. So be generic. That's the best advice I can give you on locators and stuff. So that brings us up right to the end of our session here. Peter, I want to thank you so much for joining us here. It's been a pleasure speaking with you.
Yeah, same, Paul. Thank you very much for the discussion. And yeah, thanks for pronouncing my name correctly twice.
Thank you
appreciate
so
that.
much. I appreciate it. And we'll see everybody next month in August. Have yourself a great day and stay safe and healthy, everybody. Thanks. Bye.
Thanks. Bye.